Hey there, and welcome in. I'm really glad you ended up here tonight. Maybe today stretched on longer than you expected, or maybe you're someone who finds it easier to fall asleep listening to big ideas and distant mysteries instead of counting sheep. Either way, this space is yours now. There's nowhere you need to be, nothing you need to solve. Just let your shoulders soften, let your breath slow down, and let your body feel lighter, like gravity decided to be gentle for a while. Because tonight, we're not just looking up at the stars. We're easing our way through the place we call home, the Milky Way, a massive, slow-turning spiral made of stars, dust, and unseen matter, quietly rotating through space for more than 13 billion years. It's beautiful, yes, but it's also full of strange stories. Runaway stars, invisible forces, ancient leftovers from worlds long gone. Things that don't always line up with what we thought we understood. We'll drift calmly from the glowing spiral arms into the quiet, hidden center. We'll pass through colossal encounters, brush past stars older than the galaxy itself, and touch on a story that isn't finished yet. A galaxy still assembling itself, piece by piece. Some of what you hear may catch you off guard. Some of it might simply give your mind something soft and curious to hold onto as you fall asleep. And before we really begin, if these gentle journeys help you unwind, or give you a peaceful way to close out your day, consider liking and subscribing. It helps other tired minds find their way here too, one sleepy soul at a time. Now let's begin. The Milky Way hasn't always been the quiet home it feels like. It's already crashed into other galaxies, and it will again. What looks stable and familiar is actually built from debris. Over billions of years, our galaxy has pulled in smaller neighbors, stretching them apart and weaving their stars into long streams that wrap around the disk. One of these, the Sagittarius dwarf galaxy, is being torn apart even now, and far beyond it, Andromeda is slowly drifting closer. In about 4.5 billion years, the two spirals will merge. The stars themselves will almost never collide, but the shapes of both galaxies will be forever changed, folding into something new and vast and quiet. Even galaxies grow old, change, and begin again. Some stars inside the Milky Way are older than the Milky Way itself. Not every star you see was born here. Certain stars in the halo, ancient and poor in heavy elements, follow long, tilted paths high above the disk. Their chemistry suggests they formed before the galaxy fully existed, likely inside small early galaxies that were later absorbed. They contain almost no metals, meaning they were born shortly after the Big Bang. They move slowly, like elders from a time before structure, before spirals, before order. In their faint light, we glimpse a universe still learning how to become what it is. Our solar system is moving faster than it feels. We orbit the center of the galaxy at more than 800,000 kilometers per hour, yet it still takes around 225 million years to complete a single loop. This journey is called a galactic year. Since the solar system formed, we've made this trip only about 20 times. When dinosaurs first appeared, we were somewhere else entirely. The stars around us have changed, and they'll change again. Everything moves, quietly, constantly, even as you rest. The Milky Way is still growing. Even now, it continues to collect gas from between galaxies, stars from smaller companions, and vast streams of dark matter that thicken its halo. Sometimes this growth is gentle, clouds settling in place. Other times it's disruptive, as small galaxies are pulled apart and scattered across the sky. The galaxy you live in now isn't the same one that existed millions of years ago, and it won't be the same one far in the future. It's stitched together from the remains of countless smaller worlds. Strangely enough, we're not even sure how many spiral arms it has. From inside the disk, our view is blocked by dust and distance. What once seemed like 4 neat arms now looks far more complicated. Some arms split, some fade, others twist unexpectedly. The Milky Way may not be a perfect pinwheel at all, but a layered, shifting swirl shaped by forces we're still learning to understand. Most stars drift peacefully along, but a few are violently flung away. These hypervelocity stars are ejected at incredible speeds, sometimes after a close encounter with the supermassive black hole at the galaxy's center. One star is consumed. The other is thrown outward, racing alone into intergalactic space. They're reminders that even in something as vast and graceful as a galaxy, there are sudden moments of release. High above us, Andromeda continues its slow approach. Though it looks like a faint blur in the night sky, it's coming closer every moment. When the collision happens, gravity will stretch both galaxies into long arcs. Tidal tails will unfurl. Black holes may spiral together, and eventually, after billions of years, one larger galaxy will remain. A slow, elegant dance written across cosmic time. Some stars even orbit the wrong way. In the outer halo, a few move opposite the galaxy's main rotation. These stars likely came from elsewhere, their motion a quiet signature of ancient mergers. The Milky Way remembers its past not just in light, but in movement. Over time, it has consumed many smaller galaxies. Their stars now live among ours, their histories blended into the whole. The Milky Way is not pure or pristine. It is a mosaic, assembled through gentle destruction. Every star carries a chemical signature, a record of where and when it formed. By studying these patterns, astronomers can reconstruct the galaxy's past. In this way, chemistry becomes memory, and light becomes history. Across the sky, thin ribbons of stars trace the paths of galaxies long gone. These stellar streams are quiet evidence of past encounters, stretched into delicate arcs by gravity. The Milky Way carries these scars softly, like rings in a tree, and even the disk itself is bent. Our galaxy isn't perfectly flat. It warps, rising and falling like a slow wave. This bend may come from passing galaxies or unseen dark matter tugging from below. Even something this enormous is never completely still. From far away, the Milky Way might look like it's dancing. Slowly, patiently, through the dark. When you step outside on a clear night and look up, you're seeing only a tiny fraction of what's really there. With the naked eye, even under the darkest skies, you might catch a few thousand stars. It feels like a lot. It feels endless. But it's almost nothing. The Milky Way holds more than 100 billion stars, and nearly all of them are hidden. Some are wrapped behind thick dust clouds. Others are simply too faint or too distant. That pale, milky streak across the sky is just a whisper of the whole. We're living inside a colossal river of light, surrounded by it, yet unable to truly see it from within. Stars don't all move together. Unlike planets neatly circling a sun, stars in the galaxy move with freedom and variation. Those closer to the center race along faster. Those farther out drift more slowly. This difference creates the spiral arms, not as solid structures, but as patterns. They're like slow traffic jams moving through space. As gas and stars pass through these dense regions, new stars ignite, lighting up the arms in blues and whites. Our sun has drifted in and out of these patterns over time. The galaxy isn't a clock, it's a current, and we're floating along inside it. The Milky Way shouldn't even hold together. Based on visible matter alone, it spins too fast. The outer stars should fly away, scattered into the dark. But they don't. Something unseen is holding everything in place. Dark matter. It doesn't shine or reflect light, but it exerts gravity. and there's far more of it than all the stars and gas combined. We don't know what it's made of, only that without it, the galaxy would unravel. It's the invisible framework that keeps our home intact. At the very center of the Milky Way lies something extraordinary, a supermassive black hole known as Sagittarius A. It's more than 4 million times the mass of the Sun, yet smaller than Mercury's orbit. We can't see it directly, but we've watched nearby stars whip around an empty point in space, moving so fast they trace invisible loops. Occasionally, gas falls inward and flares in powerful radiation before disappearing. Right now, the black hole is quiet, but long ago, it may have burned brightly, like a quasar, flooding the galaxy with energy. It is the silent anchor of the Milky Way's heart. The galaxy's core isn't smooth or simple. Its central bulge has a strange shape, something like a peanut or an hourglass. This form likely emerged from a dense bar of stars that runs through the center, slowly rotating and buckling over time. Gravity sculpted it patiently over billions of years. We live in a spiral galaxy, but its inner regions are complex and layered, shaped by countless orbits crossing and recrossing. The spiral arms themselves are places of birth. Vast clouds of hydrogen and dust drift through the disk. When these clouds are compressed, stars ignite within them. These stellar nurseries glow softly, lit by newborn suns. Ultraviolet light reflects off surrounding gas, painting the arms with gentle color. Every star, including our own sun, began this way, quietly, hidden inside a cloud long before it ever shined. Beyond the disk lies something far more diffuse. A spherical halo surrounds the galaxy, stretching far into space. It holds ancient stars, globular clusters, and enormous amounts of dark matter. The stars here are spread thin, orbiting slowly and rarely crossing the disk. The halo also preserves the remains of past mergers, streams and shells left behind like fossils. It's the Milky Way's outer memory, faint and patient, still shaping the future. Scattered through this halo are globular clusters, compact spheres containing hundreds of thousands of stars, bound tightly together. Many are more than 12 billion years old. Their stars are metal-poor, formed before the universe had time to create heavier elements. These clusters drift like quiet lanterns above and below the galactic plane, holding clues to the earliest chapters of cosmic history. Even now, the Milky Way continues to grow. Gas flows in from intergalactic space. Small galaxies are captured and dismantled. Dark matter thickens the halo. Sometimes this happens gently. Sometimes it leaves long scars across the sky. The galaxy, you know, is temporary, part of a slow transformation that will continue long after us. Not all stars stay where they're born. Some wander. Over time, stars can drift far from their origins, nudged by gravity or pushed by interactions. Some are thrown violently outward, becoming hypervelocity stars. Others migrate slowly, shifting inward or outward over millions of years. Even our sun likely formed closer to the center than where it is now. The Milky Way is alive with motion, quiet and constant. Star formation itself is slowing. Billions of years ago, the galaxy was more active, bursting with new stars. Now, much of the gas is thin, warm, or resistant to collapse. New stars still form, but the pace has eased. The Milky Way is settling into maturity, not dying, just calmer. Some stars formed before the galaxy had a disk at all. These ancient stars live mostly in the halo or thick disk. They formed when the Milky Way was still assembling, before its structure took shape. By studying their motion and composition, astronomers look back into a time before spirals existed. These stars are elders, silent witnesses to the galaxy's birth. A single orbit around the Milky Way takes the Sun roughly 225 to 250 million years. That's a galactic year. In the time it takes to complete one loop, continents shift and species rise and fall. The Sun has completed fewer than 25 of these orbits. On a galactic scale, we are still newcomers. The Milky Way turns in a way that defies simple physics. Stars far from the center move nearly as fast as those closer in. This shouldn't happen. Dark matter is the reason it does. Without it, the math breaks. With it, the galaxy holds together, spinning like a solid wheel guided by something unseen. The galaxy is filled with enormous molecular clouds. Cold, dark regions where hydrogen gathers. Some span hundreds of light years. Inside them, gravity slowly pulls material together until stars ignite. Others remain dark, absorbing light completely. These clouds are quiet wombs, where the future waits in shadow. Supernovae stir the galaxy. When massive stars die, they explode with tremendous force. These blasts spread heavy elements and send shockwaves through space, triggering new star formation. They destroy and create at the same time, reshaping everything around them. They are moments of chaos that keep the galaxy alive. Much of the Milky Way is hidden behind dust. Tiny grains of carbon, silicon, and ice drift between the stars, weaving dark lanes through the galaxy. In visible light, this dust blocks entire regions, swallowing stars and nebulae whole. What looks like emptiness is often anything but. Behind those shadows, stars are forming quietly. Infrared light slips through the dust, revealing glowing nurseries filled with young suns still wrapped in their birth clouds. The darkness isn't absence, it's shelter. It cools gas, protects fragile beginnings, and makes creation possible. Not every cloud becomes a star. Across the galaxy, there are massive reservoirs of cold gas that remain strangely still. They hold all the ingredients for star birth, yet nothing ignites. Some clouds are too spread out. Others are held steady by turbulence or magnetic fields. These starless clouds drift like unanswered questions, rich with potential. They may one day collapse and shine, or they may be torn apart, their material recycled elsewhere. In them, the galaxy waits. Patiently. Nothing in the Milky Way is wasted. Stars live, burn, and die, and in doing so, they return their substance to space. Red giants shed their outer layers. Planetary nebulae drift outward like glowing shells. Supernovas scatter heavy elements far and wide. That enriched material cools, mixes, and eventually becomes part of new stars, planets, and living things. Every atom in your body has passed through this cycle, forged in stars, released into space, gathered again. The galaxy is not a stage. It's a system of renewal, breathing slowly over time. Astronomers search for metal-poor stars to understand the early universe. In space science, metals mean anything heavier than helium. The first stars had almost none of them. They formed before earlier generations could create and spread heavier elements. Today, faint ancient stars in the Milky Way's halo preserve those early conditions. By studying their chemistry, scientists look back to a time just after the Big Bang, before galaxies were fully formed. These stars are fossils made of light, quietly carrying the universe's earliest memories. Stars don't always stay close to home. Over millions of years, gravitational nudges and resonances slowly change their paths. Some drift inward. Others move outward. A few are flung entirely out of the disk. Even our sun likely formed in a different region of the galaxy than where it sits now. The Milky Way is full of migration, exchange, and gentle displacement. Home, for a star, is often temporary. There may be a habitable zone within the galaxy itself. Just as Earth orbits the Sun at a comfortable distance, the Milky Way seems to have regions more friendly to life. Too close to the center, radiation and gravitational chaos dominate. Too far out, heavy elements become scarce. Somewhere in between lies a broad band where conditions are calmer and materials for planets are abundant. Earth rests within this zone, one quiet orbit among countless others that may also support life. The spiral arms are not fixed structures carved in stone. They're moving patterns, density waves that travel through the disk. Stars drift into these regions, brighten as new stars form around them, then drift back out. The arms move at a different pace than the stars themselves, like a ripple sliding through water. From afar, the galaxy looks orderly. From within, it's all motion. Beyond visible light, the Milky Way glows in other ways. Cosmic rays pass through your body every second. Radio waves hum from cold hydrogen. X-rays and gamma rays flash from black holes and dying stars. The galaxy is alive with invisible energy, a hidden symphony playing beneath the stars we can see. High above and below the galactic center float enormous structures known as the Fermi bubbles. They stretch tens of thousands of light years and glow in gamma rays. Their origin is still uncertain. They may be echoes of an ancient outburst from the central black hole or the remains of intense star formation long ago. Whatever their cause, they loom silently over the galaxy, reminders of a past that left marks too subtle for human eyes. Our solar system lives in a minor spur between larger spiral arms. We're not in one of the galaxy's grand sweeping structures, but in a quieter branch. From here, the Milky Way appears as a soft band across the sky, a gentle reminder that we are inside something far larger than ourselves. As you rest, the galaxy continues its slow turning. Stars are forming, others are fading, gas drifts, gravity pulls, time moves forward without urgency. You don't need to follow every detail. Just let the idea of it all carry you, a vast, patient system moving softly around you, holding you. As you sleep, as the night deepens, it's comforting to remember that the Milky Way doesn't rush. Everything it does happens on timescales so long they feel almost gentle. Stars take millions of years to form. Galaxies take billions to change their shape. Even the most violent events fade into quiet over time. From where you are now, resting and breathing, the galaxy is moving, but it's moving slowly enough to feel like stillness. Far beyond the spiral arms and glowing clouds, the Milky Way stretches into deep space through its dark matter halo. This invisible structure reaches far past the visible edge, forming a massive, unseen sphere that holds the galaxy together. Without it, the stars would drift apart. With it, everything remains bound. It's strange to think that the majority of our galaxy is made of something we cannot see or touch. And yet, it's there, shaping every orbit, guiding every motion. Globular clusters continue their patient paths through this halo. Hundreds of thousands of stars packed tightly together, moving as one. They've survived for more than 12 billion years, enduring gravitational tides and cosmic change. Some may have formed before the Milky Way fully existed, later captured and carried along. They glow softly, like ancient embers, reminders that time can pass without erasing everything. The galaxy also carries scars that are almost invisible unless you know where to look. Stellar streams curve across the sky, thin and faint, tracing the paths of galaxies that were torn apart long ago. These streams are memory written in motion. Proof that growth often comes from loss, that creation and destruction are never separate here. Even the center of the Milky Way, calm as it seems now, has lived through more dramatic times. Sagittarius A, the supermassive black hole at the core, is quiet today, but evidence suggests it was once far more active. Long ago, it may have consumed large amounts of gas, releasing intense radiation and shaping the surrounding region. The Fermi bubbles may be echoes of that ancient activity, lingering far above and below the disk. The past leaves traces even when the present feels still. Over time, star formation will continue to slow. The galaxy will grow older, calmer, more settled. Billions of years from now, the Milky Way may look very different. Its arms may fade, its gas may thin, and eventually, after its distant collision with Andromeda, it will become something new altogether. Not an ending, just another form. Through all of this, matter keeps cycling. Atoms move from gas to star, from star to space, from space to planet, from planet to life. Nothing is wasted, nothing truly disappears. The galaxy remembers itself by reusing its own substance again and again. It's humbling to realize how small we are within this structure. But it's also comforting. You're not separate from it. Every atom in you has traveled through this system. You are made of the Milky Way's history, its explosions, its quiet clouds, its ancient light. Right now, as you rest, the Earth turns beneath you. The moon continues its steady path. The sun carries us along its long orbit, one small part of a journey that takes hundreds of millions of years. You don't feel it. You don't need to. The galaxy is doing the work for you. There's nothing you need to understand fully tonight. No need to remember names or numbers. Just the feeling of drifting inside something vast and patient. A home built over billions of years. A system that holds together through forces both seen and unseen. Let your thoughts slow. Let the scale of it all soften into something calm rather than overwhelming. The Milky Way has room for quiet, room for rest. And right now, you're exactly where you belong within it. We live in a small stretch of the galaxy known as the Orion Spur. It's a quieter ribbon of stars tucked gently between the larger Sagittarius and Perseus arms. It isn't crowded. It isn't especially loud with activity. And that calm may be the reason we're here at all. Out here, massive supernovae are less common. Bursts of radiation don't sweep through as often. In this softer lane between galactic highways, life may have had the breathing room it needed to take shape, adapt, and slowly grow complex. From far away, the galaxy looks dramatic and blazing. But here, in this modest spur, there was enough peace for something delicate to survive. At the center of the Milky Way, things look very different. When astronomers peer toward the core using infrared light, they don't see a perfect glowing circle. They see a thick, elongated bar of stars cutting straight through the middle, a bright bridge of motion and gravity. This bar turns slowly, and its pull helps shape the inner spiral arms. Structures like this aren't rare. Many spiral galaxies carry bars at their hearts. They form when stars drift inward and begin to gather along a shared axis. Over immense spans of time, the bar stabilizes, stirring gas, igniting new stars, and funneling material toward the central black hole. It isn't just decoration. It's an engine, quietly sculpting the galaxy from the inside. Our galaxy also isn't alone. The Milky Way belongs to a small family called the Local Group. More than 50 galaxies drift together through space, bound by gravity rather than closeness. The two largest are the Milky Way and Andromeda, each surrounded by their own companions. Around them float smaller dwarf galaxies, faint ellipticals, and systems dominated almost entirely by dark matter. The Local Group spans more than 10 million light years. It isn't tightly packed, but it is connected, a loose gathering of islands linked by invisible threads of motion and pull. Despite the vast distances between them, these galaxies are not drifting apart. Many are slowly moving toward one another, caught in a long, graceful gravitational dance. Some of the smallest orbit the Milky Way like moons, looping and stretching until they dissolve into streams of stars. Others wander more freely but remain tethered. Over time, this family may grow closer. Galaxies may merge, fade, or be absorbed. The Local Group is not frozen in place. It's a slow gathering shaped by time, inertia, and gravity's quiet reach. The Milky Way's disk itself is layered. From afar, it looks like a single flat plane, but up close it has depth. The thin disk is where we live. It's dense with younger stars, open clusters, and clouds of star-forming gas. Above and below it lies the thick disk, older and more diffuse. Stars there tend to be ancient and poor in heavy elements. Their orbits are tilted and stretched, hinting at an early era marked by collisions and disruption. The disk isn't uniform. It's textured, settled in layers like sediment on the floor of a cosmic sea. Threaded through all of this is the galaxy's magnetic field. You can't see it, but it's there, stretching across the disk, rising into the halo, winding through the interstellar medium. It's weak compared to magnets on Earth, yet across galactic distances it shapes how gas moves, how cosmic rays travel, and how clouds collapse. It aligns with spiral arms, arches above the plane, and twists into patterns we're still trying to understand. The Milky Way doesn't just shine. It pulses softly with magnetism. Between the stars lies the interstellar medium. Not empty space, but a thin mixture of gas, dust, and plasma drifting like a faint fog. Invisible to our eyes, yet stunningly complex when revealed by radio and infrared light. It forms filaments and bubbles. Shockwaves ripple through it. Supernova carve out vast cavities. Stellar winds sculpt it into flowing shapes that span light years. The space between stars is alive with structure, a shifting fabric from which galaxies evolve and life eventually begins. Cosmic rays pass through you every second. High-energy particles launched by long-ago explosions race through the galaxy at nearly the speed of light. They bend along magnetic fields, bounce through clouds, and collide with Earth's atmosphere, creating showers of secondary particles. You don't feel them, but they carry stories from distant supernova and violent corners of the Milky Way. Even in rest, the galaxy is speaking in particles, in silence, in invisible motion. The Milky Way isn't perfectly balanced. Though diagrams often show a clean spiral, the real galaxy is uneven. One side of the disk is thicker. Some arms are brighter or more curved. The outer disk is warped, lopsided. These quirks likely come from past encounters, mergers, and the influence of dark matter. Like living things, galaxies carry their histories in their shapes. Scars, wrinkles, and asymmetries that give them character. High in the hollow, astronomers have found stars that may be nearly as old as the universe itself. Some contain almost no heavy elements at all, meaning they formed shortly after the Big Bang. One such star burns faintly with a red glow, low in mass but rich in history. It predates the Milky Way's structure, a living relic from the universe's earliest dawn. Not just a star, but a time capsule still shining. Closer to the center, stars move much faster. Gravity there is stronger, packed with mass from stars' gas, and the central black hole orbits Titan. Revolutions take only millions of years. Farther out, in quieter suburbs like ours, stars take hundreds of millions of years to circle once. This uneven rotation stretches and twists the disk, keeping it fluid rather than rigid. The galaxy turns like a wheel whose rim lags behind its core. Spiral arms themselves are shaped by density waves. They aren't trails of fixed stars, but moving patterns. Gas and dust compress as they pass through, triggering bursts of star formation. Bright young stars light up the arms, then drift away, replaced by new ones forming behind them. From a distance, the structure seems permanent. From within, it's motion and rhythm. Stars are born quietly from cold gas. In the darkest arms, molecular clouds chilled close to absolute zero drift unseen. Gravity slowly gathers material until regions collapse, heat, spin, and ignite. From shadow comes light. From silence, fusion. Stars are rarely born alone. Most emerge in clusters, formed together from the same collapsing cloud. These young groups can contain dozens, hundreds, sometimes thousands of stars, all bound by shared gravity. For a while, they move as a family, drifting through the galaxy side by side. But the Milky Way is not gentle forever. Tidal forces pull at them. Passing stars disturb their balance. Internal motions slowly loosen their bonds. Over millions or billions of years, clusters dissolve. Stars peel away one by one, fading into the broader galactic field. Our own sun was almost certainly born this way, among siblings that are now scattered across the sky, distant and mostly unknown. Among the rarest objects in the galaxy are hypermetal poor stars. These stars contain almost no elements heavier than helium. Some have less than 100,000th the iron found in the sun. They likely formed just after the very first supernovae, when the universe had barely begun enriching itself. These stars are ancient beyond measure, drifting through the halo like faint lanterns from the dawn of time. Each one carries the chemical imprint of a universe still taking its first steps. Planets, however, are not rare at all. Wherever stars form, planets tend to follow. As a newborn star ignites, a rotating disk of leftover gas and dust surrounds it. Within that disk, grains collide, stick, and grow. Pebbles become boulders. Boulders become worlds. Across the Milky Way, planetary systems take shape in staggering variety. Some host massive gas giants. Others hold tightly packed rocky planets close to dim stars. Some systems may resemble our own. Others look nothing like it. The galaxy is not just filled with stars. It's filled with families of worlds, each following its own quiet balance. Our solar system sits near a special region called the corrotation radius. Spiral arms rotate as patterns, not as solid objects. Stars move through them at different speeds. But near this boundary, the speed of stars and the speed of the spiral pattern nearly match. This may mean the sun avoids frequent passages through dense spiral arms, where supernovae and gravitational disruptions are more common. It's possible this gentle resonance has helped keep our environment relatively stable over long stretches of time. As the sun orbits the Milky Way, it doesn't stay perfectly level. It bobs up and down through the galactic plane in a slow wave, rising and falling over tens of millions of years. This motion is caused by the combined gravitational pull of the galaxy's mass. Some researchers have wondered whether this oscillation might influence long-term patterns on Earth. The idea is still debated, but the motion itself is real. Even on its steady path, the sun sways softly through space. Dark matter remains one of the galaxy's deepest mysteries. It makes up most of the Milky Way's mass, yet it cannot be seen or touched. It doesn't emit light. It passes through ordinary matter almost without interaction, and yet its gravity shapes everything. Without it, the galaxy would fly apart. Astronomers detect dark matter not directly, but by watching how stars move, how galaxies rotate, how structures form. It is the unseen framework holding the galaxy together. Most of the Milky Way's mass lies outside the bright disk. The stars we see are only the glowing surface. Beyond them stretches a vast halo dominated by dark matter, sparsely populated with ancient stars and globular clusters. This halo outweighs the disk by a large margin. When we picture the Milky Way, we imagine its arms and luminous band. But its true size and weight extend far into the dark. There is evidence that the galaxy's core was once far more active. Though Sagittarius A is quiet today, massive gamma-ray structures and echoes of high-energy light suggest it may have flared long ago, briefly shining like a quasar. If so, the Milky Way would have looked very different, its calm spiral wrapped around a blazing center. That era has passed, but traces remain. Over billions of years, the galaxy's structure continues to change. Bars form and weaken. Arms shift, gas flows inward and outward, the disk ripples and warps. Encounters with smaller galaxies bend and tug at its shape. The Milky Way is not frozen, its beauty lies in motion and transformation. Across the universe, violent mergers send out gravitational waves. Ripples in spacetime itself. Some of these waves pass through the Milky Way, distorting space by tiny, immeasurable amounts. We can't feel them, but instruments on Earth have begun to detect these whispers, confirming that even now, space itself is moving. Not all stars follow neat circular paths. Some orbit on long, tilted ellipses plunging high above and far below the disk. These stars are often relics of ancient mergers, survivors of systems torn apart long ago. Their unusual motions help astronomers map the galaxy's hidden mass and reconstruct its past. The Milky Way is flooded with neutrinos, ghostly particles born in stellar cores, supernovae, and cosmic ray collisions. Trillions pass through your body every second without leaving a trace. Only massive detectors buried deep underground or beneath ice occasionally catch one. Neutrinos carry information from places light cannot escape, whispers from the galaxy's deepest fires. Interstellar space is turbulent. Gas flows collide, shock waves ripple. Magnetic fields twist and stretch matter into filaments. On large scales, the interstellar medium behaves like a slow, restless sea. Star formation, cosmic rays, and galactic evolution all emerge from this motion. There may be countless rogue planets drifting through the galaxy, worlds torn from their stars or formed alone, wandering cold and dark. Some may even inhabit the halo. These orphan planets travel silently, warmed only by internal heat, following lonely paths through the dark between stars. Dust grains dance to magnetic rhythms. Tiny particles align, spin, and glow faintly under the influence of galactic magnetic fields. Their behavior helps astronomers trace invisible structures and better understand the galaxy's hidden forces. In rare events, neutron stars collide, forging heavy elements like gold and platinum. Some stars carry the chemical fingerprints of these cataclysms. They are records of cosmic violence written into light. The galaxy's center may contain not one bar, but two, a smaller inner bar nested within the larger one, rotating at a different angle. This layered structure helps funnel material inward and adds complexity to the core's motion. Gas continues to flow into the Milky Way from the cosmic web. Long, tenuous streams feed the galaxy, sustaining star formation and linking it to the larger universe. The Milky Way is not closed, it is connected. When massive stars die together, they reshape the galaxy around them. Clusters of supernovae can hollow out enormous cavities in the interstellar medium, creating vast bubbles of hot gas. These bubbles sometimes merge and punch through the galactic disk, forming chimneys that vent energy and matter into the halo. Through these channels, gas, metals, and magnetic fields rise and spread, helping regulate star formation and recycle material. In this way, the Milky Way doesn't just rotate, it breathes. Though the galaxy appears calm in visible light, it shines fiercely in X-rays. Collapsed stars, black holes, and hot gas emit high-energy radiation invisible to our eyes. Matter spiraling into neutron stars and black holes heats to millions of degrees. The halo itself glows faintly in X-rays, revealing the galaxy's extended skeleton. Different wavelengths show different galaxies layered on top of one another. Pulsars are among the most precise clocks in the universe. Spinning neutron stars sweep beams of radiation across space with astonishing regularity, some hundreds of times per second. Astronomers use these cosmic lighthouses to test gravity, measure distances, and even search for gravitational waves. Across the Milky Way, they tick steadily, remnants of stellar death that keep time for the cosmos. Radio waves reveal what light cannot. They pass through dust, tracing cold hydrogen gas, mapping spiral arms, and outlining magnetic fields. With radio telescopes, astronomers see the hidden architecture of the galaxy's star, forming regions cloaked in darkness, supernova remnants expanding into space, and signals from far beyond the Milky Way itself. The Sun was almost certainly born in a stellar cluster. Long ago, it shared space with many sibling stars, all formed from the same cloud. Over time, that cluster dissolved, scattering its members across the galaxy. Astronomers now search for these lost siblings, stars with matching ages, motions, and chemical signatures. Somewhere out there, distant suns still carry a shared origin with our own. The Milky Way's disk is not flat. It wobbles and warps, bending upward on one side and downward on the other. This slow undulation may be caused by interactions with satellite galaxies, dark matter, or internal instabilities. From afar, the galaxy is not a perfect spiral, but a gently rippling sheet of stars. Galactic tides stretch and unravel smaller systems. Star clusters and dwarf galaxies feel uneven gravitational pulls that draw out long streams of stars. Many of the faint arcs mapped across the sky are the remnants of these slow disruptions. The galaxy rarely destroys abruptly. It unravels patiently. Even the mass of the Milky Way is uncertain. Most of it lies in dark matter, invisible and difficult to measure. Estimates vary widely. Our home galaxy's true weight remains an open question. The Milky Way may even outweigh Andromeda. Though Andromeda looks larger and brighter, new evidence suggests our galaxy's dark matter halo may be broader and denser. This matters for the future because the two galaxies are moving toward each other. When they merge, mass will shape the encounter. The Large and Small Magellanic Clouds may be recent arrivals. Their motion suggests they could be on their first close pass around the Milky Way. Their presence has already warped the outer disk and stirred the halo, a reminder that even now, the galaxy is responding to new gravitational guests. Trailing behind them is the Magellanic Stream, a vast ribbon of stripped hydrogen gas stretching across the sky. Torn away by tidal forces, it may one day feed new star formation or settle into the halo as a lingering memory of motion and loss. Not everything orbits in the galactic plane. Some gas clouds and stars move on polar or highly tilted paths, relics of past mergers and captures. These misaligned orbits record the galaxy's history of disruption and growth. In several regions, giant shells of gas surround ancient starbursts. These spherical remnants mark where massive stars once formed and died in rapid succession. Though long faded, their cavities remain etched into the interstellar medium. In the densest regions, stars can collide. In globular clusters, close encounters may merge stars or create unusual objects like blue stragglers. Though rare, these collisions remind us that even in space, crowding can matter. Binary stars can be torn apart. Passing near the galactic center or through dense clusters, gravitational tides can fling one star away while trapping the other. Some of these stars are hurled completely out of the galaxy, becoming hypervelocity stars. A few stars escape the Milky Way entirely. Accelerated to extreme speeds, they travel alone into intergalactic space, carrying with them the memory of their origin. Tiny beacons drifting far beyond the spiral's edge. Not all stars in the Milky Way were born here. Some were captured from other galaxies during mergers, now moving on strange orbits through the halo. They are immigrants of light, bearing stories from other skies. Gas cycles between the disk and halo in a galactic fountain. Heated by supernovae, it rises, cools, and falls back down, redistributing elements and regulating star formation. The galaxy inhales and exhales across millions of years. Interstellar dust carries complex organic molecules. Carbon-rich compounds drift through space, formed in dying stars and cold clouds. These grains may seed forming planets with the raw ingredients for life. Star-forming clouds inherit these ingredients. As solar systems take shape, they receive the chemical legacy of their birth clouds. Water, carbon, and complexity arise naturally in many regions of the galaxy. Some stars spin at astonishing speeds, rotating in hours rather than days. These rapid rotators are often massive and short-lived, flinging material into space and living brief, intense lives. The galactic plane is tilted relative to our solar system. This is why the Milky Way arches across the sky at an angle, shifting with the seasons. We are part of the galaxy, but slightly askew within it. Some stellar remnants are older than the disk itself. Ancient white dwarfs in the halo hint at star formation before the Milky Way fully settled. They are quiet witnesses to the galaxy's early days. The farthest stars orbit in the deep halo tens or hundreds of thousands of light years away. Sparse and faint, they define the galaxy's true reach. The Milky Way is subtly lopsided. Its arms, disk, and halo show asymmetries shaped by interactions in time. Its beauty lies in this imbalance. Variable stars act as cosmic yardsticks. By measuring their rhythmic pulses, Astronomers map the galaxy's shape and scale. The Gaia mission is transforming our understanding of the Milky Way. By charting the positions and motions of billions of stars, it reveals the galaxy in 3 dimensions and through time. On dark nights, we see the galactic plane as a river of light. We are looking along the dense disk, peering into the galaxy's richest corridors. The sky grows brightest toward the galactic center. Though hidden by dust, it glows with the combined light of countless stars. Because we live inside the Milky Way, we see it edge on. It took centuries to understand the spiral we belong to. And even now, we see only a fraction of what exists. Much is hidden, much is inferred. The Milky Way holds ancient light and future stars, drifting worlds and unanswered questions. And within it, we find ourselves.